The unveiling of the Great Dying Mass Extinction and its modern-day implications. Imagine a time when our planet experienced its most devastating loss of life, about 252 million years ago, an event known as the Great Dying. This catastrophic mass extinction obliterated nearly 90% of all living organisms on Earth. Following this calamity, our planet endured temperatures soaring to lethal levels for a staggering 5 million years. But why did this happen, and what can it teach us about our future? A collaborative team of international researchers has turned to a treasure trove of fossil records to uncover new insights, which could also serve as a stark warning about our world's future as we continue to emit greenhouse gases from burning fossil fuels. Unraveling the greatest extinction mystery. What has left scientists puzzled for ages is the reason behind the prolonged intense heat after the end of the volcanic activity. The Great Dying is known as the most severe of the 5 ancient mass extinctions, marking the end of the Permian period. It is widely believed that immense volcanic eruptions in the Siberian traps released massive quantities of carbon and other greenhouse gases into the atmosphere, leading to extreme global warming. This triggered the death of numerous marine and terrestrial species, the collapse of ecosystems, and the acidification of oceans. But here's where it gets controversial. Some theories suggest that the oceans might have played a critical role by losing their carbon-absorbing plankton or undergoing chemical changes that reduce their ability to sequester carbon. However, researchers from the University of Leeds in England and the China University of Geosciences propose a different angle: the collapse of tropical forests as a climate tipping point. The importance of trees in the carbon cycle. Benjamin Mills, a professor from the University of Leeds, emphasizes that the Great Dying is unique in that it involved the widespread extinction of plant life. This massive deforestation significantly reduced the planet's capacity to store carbon, leading to elevated atmospheric carbon levels. Forests play a crucial role in regulating Earth's climate by absorbing carbon dioxide and participating in the silicate weathering process, a vital mechanism that removes CO2 from the atmosphere via chemical reactions involving rocks and rainwater. When these forests vanish, the Earth's carbon cycle becomes disrupted. Is this the tipping point for our planet? Professor Michael Benton, a paleontologist, highlights the researchers' importance in understanding how the loss of forests can maintain high CO2 levels for an extended period. This phenomenon ensures that changes need to be continued while a strain of forest abandonment. This forest cycle is exactly the mechanism that can end up in strain causing conservation of bacterium disruption. The bottom line of the study is a crucial standing, but if this forest cycle is damaging the atmosphere, but it's not doing its job. Kill enough even if we cease carbon emissions now. The turn will be the future making said carbon. But is there hope? The study suggests that today's tropical rainforests might be more resilient to heat compared to those in the ancient past. This question forms the basis of their next investigation. But it's kind of a brief tale of how serious climate change is not going to get, but it's quite a memorable one. From this log, the stomach is best explained. What if this could be so clean and do? Do we realistically avert this crisis and pull to in monster level?